All right, so today's lesson is lesson 6.4, and we're going to continue with this whole notion of how we can use ratios in real life. And so today what we're going to talk about is probability. All right, so let's look at probability. The probability, you probably all know, probability is the chance of something happening. And I've got two guests that are going to be helping me today. We got Will Medley from the ISM class, and we've got Molly McClay. So thanks for helping out, guys. And so let's get started with a definition. Okay, now the book's definition of what the probability of an event is it defines the probability of an event to be the number of favorable outcomes divided by the number of possible outcomes. So in other words, what that basically means is when you do the probability of an event, it's the ratio of the chance it actually happens divided by the total number of chances. Okay? So a good example for that is, let's say we had a bag of marbles. Okay? And let's say the marbles in the bag, let's say it contains 3 red marbles, 4 blue marbles, and 5 green marbles. Well, the first thing we need to figure out is we need to figure out the total number of marbles in the bag, which, Molly, you already told me is what? If you add those up, you get 12. Okay, 12. So we're going to put a little note over here that the total equals 12. So remember that. You're going to need it for each of these. Okay, so the probability that I get a red marble, well, there's 3 red marbles. That's the chance of something happening, divided by a total of 12, which reduces to what, Will?
It reduces to 1 over 4.
1 over 4. So the chance of getting a red marble is 1/4. Okay? What are the chances of getting a blue marble? So what's the probability of a blue marble?
1/3.
Okay, well, first, how did we get that, though, first, Molly? So probability of blue, how many blue marbles?
4.
4 out of 12, which you already said reduces to 1/3. Okay, agreed. And the probability of green, oops, that's a G. Okay, probability of green, we have 5 greens total out of a total of 12 marbles, so it's 5/12, and that one doesn't reduce. Okay, so we get 5/12. Let's go back and circle the probability for blue, it's 1/3. So that's the basic probability. You've also seen probabilities like when you flip a coin. Okay, so when you flip a coin, what's the probability you get heads? Well, that's 1 of the 2 sides, right? So it's 1 out of 2. The probability that you get maybe a number on a die. Let's say you roll a 6-sided cube die, normal die. What's the chances you get a 3?
1 out of 6.
1 out of 6. What's the chances you get an odd number?
1/2.
Well, 3, no, careful.
3 out of 6.
3 out of 6, which reduces to 1/2, right? And same thing for even, it'd be 3 out of 6. So anyway, so that's the idea. Now, Molly, what's the chances you get a 5 or a 6?
2 6.
2 6, which reduces to
1/3.
1/3. That's it. So that's the probability. We can also do probability if we draw cards from a deck, things like that. Okay, so let's move ahead. All right, now if we take these probabilities, we wrote them all as ratios or fractions, but we could also write them as decimals. And if we think of probabilities as decimals, they're all going to be between 0 and 1. In fact, what's the probability of 0? It means that something is guaranteed
not to happen.
Okay, so basically,
0.
a probability of 0 basically means that something is impossible. Okay? On the other end of the spectrum, what would a probability of 1 mean?
Certain.
It's absolutely certain. Okay? It's guaranteed to happen. Okay? Most probabilities are going to be somewhere in between here. Okay? If it's exactly a 50-50 chance, okay, then it would be right in the middle. It would be a probability of 1/2. Okay? Now, another definition that we need to know is the idea of complement. Okay? Now, the complement basically means the opposite. So, for instance, suppose something has a 3 in 5 chance of happening. Okay, so let's say we've got 5 choices, 3 of them are favorable outcomes out of a total of 5. The complement of that would be, what are the chances it doesn't happen?
2/5.
2/5, right? It's the opposite. And in fact, if we take a probability and its complement and we add them together, we ought to get 1. Okay. Now, complements could also be kind of split. We don't really call it complement, but you could also break it into parts. So let's go back to the example we had before of the red, the blue, and the green marble. You got to get one of those colors, right? Turns out if you add 1/4, 1/3, and 5/12 and get your common denominators back, look at the original fractions, 3/12, 4/12, and 5/12. If you add those all up, you get 12/12. It adds up to 1. Now, we don't actually call it complement when it's 3 different events, but it's the same idea. Okay, so the complement is If the probability is the chance that something happens, the complement is the opposite. The chance that it doesn't happen or the chance that the other thing happens. All right, now we have one more big thing that we need to talk about, and that's odds. Now, odds and probability are confused most of the time by most people. So let's be smarter than the average person. When we're doing probability, we just defined it. When we defined probability, we said it was the chance of something happening divided by the total number of chances. In other words, it's the part divided by the total. Probability is actually more like a fraction, the way we've been talking about lately, where it's part out of the total. Whereas odds are going to be more like a generic ratio. We're comparing one part to another part. Let me give you a good example. Suppose we have a class, and suppose that right now in the class there are 3 girls present in the class and there are 5 boys in the class. Okay, so to illustrate the difference here, okay, if I did the probability, if I pick somebody at random from the class and ask them to go do something, there's 8 total students in the class, right? I add the 3 and the 5 together. The probability that I pick a girl would be 3 out of 8. The complement of that would be the chance I pick a boy, that'd be 5 out of 8. In both of those cases, I'm dividing the number of girls or the number of boys by the total number of people in the class. Okay, you don't do that with odds. With odds, you compare one part to the other part. So if I was doing odds in this example, I would say there are 3 girls to every 5 boys. Or I could write it as 3 to 5 with the colon, like we did with ratios in the first lesson. Or I could write it with the word 2, 3 to 5. Notice here I'm comparing part to part. Okay, and that's with the odds. Okay, so sorry, we had a little pop-up that interrupted the video. So once again, with probability, we're looking at part out of the total. With odds, we're looking at part to part. Now, you can convert back and forth between the two. To change odds into probability, what's going to be necessary is we're going to need to add the 2 parts together to get the total. Okay? If we have probability, what we're going to do is subtract the total minus one of the parts to get the other part. Okay, so we can convert back and forth between probability and odds. The difference is probability is the chances of something happening divided by the total, whereas odds is the chances of something happening to the chances of something else happening. Okay, and generally speaking, there is that word that we had before, the complement. Usually when we're talking about odds, we're looking at the odds of something happening to the odds of them not happening. So odds do kind of fit in with complements. So the idea of complements with probability is similar to the idea of odds. Okay, we'll practice that. I know that's a little confusing, so we'll practice that in class tomorrow. But thank you very much for watching our video. And tomorrow in class, we'll be practicing working with probability and odds. And that will pretty much wrap up the first year before we go away to our holiday break. So thank you all for watching. We'll see you tomorrow in class.
Hooray, holiday break is fun.
Bye.
Bye.